line moves.
There it is.
I think that's it. I believe we're
No,
on.
now you're
No?
on. Now you're on.
Hey! Hello, everybody. I'm Ronnie Herron, your proud host of the SBAU Astro Hour, which may not have as big a following as Neil deGrasse Tyson's Startalk. But hey, we're growing. Our astrophysics club, the Santa Barbara Astronomical Unit, does cover as much, if not more, cosmology, stuff that's changing out there, as any other YouTube blog podcast. Myself and the SBAU Brain Trust on the screen have been meeting together here for over 4 years now, and incredible topics like this week, we're going to talk about the shadows of Saturn's rings being cast on the planet. Tonight's Eta Aquarian meteor shower as Earth slams into Halley's Comet debris. Going to focus on M17 out there, also known as the Swan or Omega Nebula. Our Earth's magnetic field gets stirred up last week by coronal holes. Oh my God, they're from the sun. I've had that problem with my couch. I had it reupholstered because
Yeah.
solar flares or solar super flares. Actually, shouldn't they be called stellar? But that's all right. They're sun-like stars, and they're throughout our galaxy. We'll talk about it with the president and everybody else. We meet up at the Museum of Natural History, and we've been around a long time, and we're into our 5th year of talking together. Only one person not on screen. We'll talk to the man in charge, the captain of the Starcraft, Jerry Wilson. It's been 8 years now, right? I think I followed right behind you and replaced Adrian a year later, so it'd be 7 for me. But
Wow.
nice to see Pat Forgy at Saturday's part of the Star weekend of the astronomy party we had out at Camino Real. Chuck McPartland is on screen, outreach coordinator. His wife is also named Pat. Pat McPartland is the merchandise, as well as an incredible treasurer. We had Tim Crawford sign in. He's married to the lovely Karen and a telescope expert and really doing his thing with the people that showed up on Sunday at the museum yesterday. Learned a lot. And Tom Whittemore signed in. He's married to Maureen, former Westmont College beloved professor, now retired, baking bread. Had a nice discussion with him as I looked through the museum's telescope inside Palmer Observatory. Learned all kinds of things. Missing from the screen this week is Mr. Bruce Murdoch, but he may sign in yet, or he may have a doctor's appointment. Gentlemen, let's get silly. Let's go to the silly cartoons. We have a few of those and some real thought provokers that the president manages to call new ones, mostly new ones, every week. And they're going to come on the screen now, and we're going to archive incredible stuff. I will comment and let you guys read some of them too.
I saw this one. Crack
I
me
didn't
up.
see this one. Insane fact: the sun is approximately eight. Oh, I did. This is the best one you got.
Yeah.
It's about 8 CVS pharmacy receipts away from the Earth. Don't forget, you got to have your phone number with them so they can ask if they can. You never get a discount, but they want to send you stuff. That's funny. That's great. That's how far it is away. Okay. Next. Extraterrestrials looking through their scope. And I guess that's an exoplanet. It detected a planet out there that may support intelligent life, and they looked through it and sorry, false alarm. They're humans. No intelligent life here. That's a good one. That's a common theme. Now, this is what's inside Jupiter. Boy, this was a whole subject of much of one of our hours. Current leading theories for what's in the center of Jupiter, Mr. President. You want to run down those 8?
Up here, diffuse mix of heavy metals and metallic hydrogen.
Okay.
Alternately, rocky core with metallic hydrogen mantle. Here, valuable treasure.
Ooh, that's where it all is.
Emergency backup Earth.
Okay.
Regular planet pretending to be a gas giant to avoid attention.
Okay.
Hardball from avocado.
Oh, yeah, that's right. You could.
Baby Jupiter still gestating.
Ooh.
Or flat Earth conspiracists are wrong about Earth, but right about Jupiter.
That's my favorite. My favorite there.
What somebody said they were affected by, or I certainly was, something the speaker, the lovely Katie Wimberley, said from CSU San Berndoo about hydrogen is considered the gas the elements? Everything else is a metal. Have you ever heard
Hydrogen
that?
and helium.
Hydrogen and helium are the only two gases, even
Not
though
gases, they're non-metals.
Right.
okay, but that means your neons, your argons, your xenons,
They're all
oxygens,
metals.
they're all metals. Oxygen, nitrogen. Here we go. I didn't get
This
this
is
one.
one you guys have not seen. Shows a piece of toast with a space helmet on. And he's flying up out of the toaster, and there's mission control cheering him on, but he didn't make orbit.
Little EVA there out of the toaster, a little extravehicular activity or whatever they call it. That's funny. So you are getting some new ones. We had a
This is
couple
pretty good.
repeats.
This one,
here's-
this one is washed out, so it'll be hard to get the punchline.
Oh, sorry.
Yeah.
Not for me, it isn't. Guy is announcing NASA announces a bold plan to somehow still exist by 2045.
Yes,
It'll
but
all
what
be-
you don't see is that his name is Charles Bolden.
Charles Bolden?
Yes,
Who is it? Who is Charles
Oh,
Bolden?
I see.
he was NASA director.
He was before the current guy?
Yeah.
Okay, well, what you suppose Elon would love his SpaceX to replace NASA, or is that possible?
Just replace NASA's money.
Just the money. Okay, get
Just wants the
everything
money.
else.
And finally, here's a guy that misread the email, and he came dressed in a spacesuit.
Or he overslept.
Yeah.
He showed up for the launch in his PJs. That's a good one. I like it. To say twonks, what does that mean? I guess
What's
that's
that?
the name of the cartoon series.
Oh, I don't know.
All right, we got lots to talk about, and I got lots to learn, and you guys know most of this. I would like you, Tim, to raise your hand every time you learn something new, and I'll do the same thing.
Well, I'll just keep my hand up.
Oh, here it is. Really, you can see the shadow.
Yeah,
Amazing.
this is a picture taken by, I think it was Cassini, and of the rings in about the same aspect that they're visible from the Earth right now. We just passed through the period in late March where the rings disappeared from our view, but Saturn disappeared from our view too. It was on the other side of the sun. The rings are
Wow.
very slight, and it's possible with a larger telescope to see the shadow of the rings on the ball of the planet.
Really? You mean they're not permanently on there?
No, well, it depends on no, they're not. And they're faint. They're hard to see. This is a processed image.
And how easy they see depends on your viewing angle, Ron.
Right.
Oh, I see. Okay. But it is because I think Saturn is as far beyond Jupiter as Jupiter is from us. It's like twice as far, isn't it?
Yep.
Roughly.
So I mean,
It's a good
Jupiter-
estimate to start with Mercury and then just double the distance each time, and
Good Lord.
that works fairly well.
Mhm.
Are we going to feature Saturn when that ring goes invisible? Side
It already
on?
did, Ron. It already did, and Saturn was near the sun in the sky. We couldn't see it.
It
I
passed
think
by us, and I must have missed out. I was snoring during that.
It was late March.
Oh, was it really? Okay. Amazing.
So the best way to see this, according to Astronomy Magazine's author Stephen James O'Meara, recommends glancing toward the bright ends or ansae of the rings. And ansae is a oops.
The Latin word for handles.
Yeah, okay.
Mhm.
So we'll get to that in a minute, I guess. I jumped ahead. So this is where Saturn is. This is about 6 in the morning. You can see the planetarium program puts the rays of the sun over here. This does not correspond to my background here. But this is Venus, Neptune, and Saturn in a tight grouping. Here it probably rises around 4 a.m., I would say. So, and Mercury is now in the morning sky also. So this is the finder chart. There's Aquarius, which we'll get to when we get to the meteor shower stuff.
Mhm.
And this is at the time, same time as the previous finder chart. This is what the configuration around Saturn will look like. Here, the rings are very close to being invisible, but they are opening up now again. This is most of their visible, they're easy to find moons, but I think they have a number of moons that's north of 100 now.
274.
It's north
Oh
of
my
200.
God.
Wow.
It went up again?
Well, it just went up by 128 like 2 months ago.
Oh, wow.
Well, that picture a while ago you showed, what you said was an artist rendering of the shadow of the rings.
It
No,
wasn't an artist rendering, Ron. That was a picture.
Yeah.
Oh, that came from Cassini.
Yeah.
Yeah.
Oh, that was going to be my question. It must have sent a lot of
Yeah.
pictures like
Two of their moons are shown there, but I don't know which ones.
It's amazing that the sun delineates the different little rings, the little ones that let sunlight through, and it's not just one big black
Yeah.
tire. Wow.
These rings are not solid things. You can see the sunlight, a lot of sunlight gets through a lot of them.
They're more like clouds of particles.
Yeah.
There's little shepherd moons inside them too that are guiding.
Some of the rings have shepherd rings, some of the narrow little rings, and some of the gaps are caused by shepherd moons.
Huh.
A
So
lot
this
of the
shows,
structure it's caused because you have all these moons going around and they tend to be in integer ratios. And so you get an effect like pushing and pulling someone on a swing, where if you do it always at the same point, you build up a big amplitude and it throws particles out of some of those orbits.
But those shepherd moons are not considered as part of regular moons?
Sure.
no, they're part of they count as moons too.
Okay. Are they listed? Is that what those things are? Oh, those are only rings. E ring, F ring.
Yeah, this shows the structure of the rings. If you squint, you see these rings as a ring, and you see this as a ring, and then this dark thing between them is the big
The big gap.
Cassini
yeah.
division.
That's it. They're
Was that what it's called?
division.
And we didn't know any of this before Cassini was sent up there, what,
No,
30
we
years ago?
did. The Cassini division is named because Cassini saw it.
Yeah.
That's
Is
what I
the
meant.
D-
But
And Ron, if you really squint, you can see the onion ring.
welcome to the Outback, folks.
There you
And
go.
when I'm sorry, Ron, when I said Cassini, I didn't mean the Cassini spacecraft. I meant the astronomer that the
Astronomer.
Cassini spacecraft
Oh,
was named after.
What century was he in?
It was early
He-
1700s, I think.
Yeah.
He could see the division of the rings. Wow.
Oh, it's
Which one of these rings is known as the crepe ring? Is it the D or C ring?
C.
It's the C ring. Okay.
Yeah. Yeah. I've seen that at 12.5, Tim.
What does that mean, crepe ring?
Just the
It's
name
very
for it.
faint.
Oh, okay.
I took the same photograph and I put the Earth and the Moon to scale in it, and it's outside of the F ring. It's out there in the nebulous stuff.
Hello,
But then
Bruce
it-
Murdoch. Welcome to
Yes.
the gang. We can introduce you now, Bruce.
Oh, hi, Bruce.
Good to have you
Hello.
on.
Yeah, I got involved in doing some gardening, and time got away from me.
Okay.
Okay. We knew you were doing something important. So you got a picture of like this, Bruce? You could
I
send
have a
us?
picture like this. It doesn't have the labels. It's just the back view. This is the opposite side of Saturn from the sun, so it's blocking the sun. And
Okay.
I took the picture and brought it in Photoshop, and to scale, I put the Earth and the Moon in it too, just to see how big it is. Because the
Okay.
Moon is 250,000 miles from the Earth, and it goes outside. It's outside the G ring. If you want, I'll find that and load it up here.
But Mr. President, is it only going to be a couple days we see the shadow on the surface of Saturn?
No,
Uh,
it's only a
appar-
couple of. Go ahead, Ron. Go ahead. Jerry.
Oh, no, I was just going to profess ignorance.
No, the shadows can be visible fairly often, but it's not often that they're really spread out the way they were in that picture. And it's more like it's a short period of time when you don't see the ring.
Okay. But do you ever see them? Any of you guys on your scopes?
Yeah.
I've
Oh,
I've
yeah.
never looked I see the rings all the time. I've never looked for the shadow of the rings.
I had an amazing time up at the gun club when we were up at about 2 in the morning, and Joe Doyle had his big 18-inch scope and told me to take a look with my good eye, which was neither one of them. And I went ahead and looked, but boy, it was to date the best view I've ever seen of Saturn. And yes, the shadow of the ring was
Oh,
cast
you saw that.
on.
Okay, good. Anyway, Omira says to look at the Ansei, which in a small scope is this area of the ring and this area of the ring. But I don't
Okay.
understand why you would look here to see something up here.
Maybe it's to get it on your rods.
Yeah, oh, that's right. Averted vision.
Yeah.
Good point.
And something that's cool too is you can see the um, shadow of Saturn on the rings.
Oh, yeah. Yeah.
Oh, wow.
So
I just
technically,
realized you're looking upwards at Saturn. You're looking at the bottom side of the ring here.
that's what
Yes.
I was about to say. Yeah.
Because there's the bottom of the far side of the rings.
Yeah.
Here's the bottom of the near side of the rings.
Or you can
Well,
say Cassini was looking at the bottom and we were looking at the top.
Oh, yeah, that's coming up.
why does it change configuration when it goes across the planet?
It's dark.
Looks different.
I don't understand what you mean.
Well, the most inner ring is wider on the planet of what we're looking at. This side is the upper side that comes around our side, our view.
Yeah, we're looking from the bottom up.
But those lines on the planet itself don't match the ring on the side, the ears.
Well,
Well,
there's a big difference in brightness between what the ring in back of the planet, because it's in the shadow of the planet, and the ring outside, which is being illuminated by the sun. And somebody brought this through Photoshop and put a mask around Saturn and tried to bring up the brightness on Saturn itself. So it doesn't look quite right.
Yeah, you can see, as Bruce is pointing out, you can see little artifacts of the construction of the image.
Yeah, that was his mask.
Yeah.
The outline of the mask.
But
He didn't do the right thing.
what does your "and" say again?
the
It's
ends.
Yeah, it's just
The
an
what?
old word for the thing that's farthest away from the planet. The things that Galileo thought were handles.
Oh, so the word is "ensae," E-N-D?
No,
ANSAE.
ANSAE, Anse,
Ansae. Okay, that's
plural
French.
of Ansa.
Gotcha.
Okay. The coming up tomorrow morning, Tuesday morning, is the best time for the Eta Aquariid meteor shower. We're going to cross the orbit of the debris left behind by Halley's Comet. And it should be a good meteor shower if the skies are clear. For here, that might be problematic.
Good luck.
But the shower is famous for producing large fireballs or bolids, which leave an orange trail or a smoky trail and can be quite bright. And you can sometimes see flames coming out behind it,
Wow.
or rather waves in the debris coming off. So this is where's Aquarius? There. So this is in the morning. This is about 5 in the morning, but you can see the meteor shower starting at midnight. That's when you're on the front end of the Earth. So if the Earth were a car moving through the rainstorm, you're looking out the windshield starting at midnight. You're on the front end of the Earth going through the sky. And that's when meteors, then you're going to run into the meteors, and that's when you see more of them. In the evening, the meteors you see have to have extra energy to catch up to the Earth. So we'll be picking them off like bugs on the windshield after midnight, and the radiant is here in this is where they appear to come from. This does not have to be up. There's a big band, an annulus around here, like a big washer in the sky, the washer that goes with a bolt and nut, not the washer for your laundry. And so you'll see this part of it right around midnight or so. So you'll still see things coming up. Any comments?
Yeah, I got a question. Do they name any meteor shower after the comet that left the debris rather than the radiant location? Why isn't this called Halley's meteor
There's
shower?
two of them. There's two from Halley's Comet.
Oh, there are. We crossed this tail area twice.
Yes. We talked
In our
about that
orbit.
last week, Ron. In October, it's the Orionid shower, and that's pieces of Halley's Comet. And then we have the Eta Aquarids, which is pieces of Halley's Comet.
I believe the names of the meteor showers came first. It took some research to figure out which comet orbit is the stuff full of debris.
Yeah, they used to have names like Tears of St. Lucy and stuff like that.
Mm.
Well, I only knew a couple when I grew up, Leonid and whatever the other ones were.
Perseids.
Perseids, probably.
Perseids, yeah.
And before they really knew what comets were, they called them stars with hair or bearded stars.
Yeah. Yeah, coma is hair.
Mhm.
And
But
Saturn had big ears.
Yeah.
Yeah, exactly.
And
This was
gigantic.
a really cool photo.
This is a composite photo made by an amateur in Australia of the Eta Aquariid, I think in 2022.
Mm.
Whoops.
Well, he lives in the outback in Australia. I've been there, and it's wonderful.
Yeah.
Oh,
Dark.
I'll bet the night sky is awesome in the outback.
He lives in a town called Tuborak in Victoria, Australia. So this shows 66 Aquariid meteors on May 5th and 6th, 2022. He took the picture between 2:30 a.m. and 5:45 a.m. with a
So
night.
pretty much all the falling stars you hear about in children's stories and poems are meteors, aren't they?
Yeah.
And they're probably always connected to a shower happening.
No.
No, we get meteors all the time.
Mhm.
Do we?
Individual ones, yeah.
It's not
50
always
to 100 tons a day.
really.
He must have used a flash or something because the Earth is turning in 2 hours, yet the foreground is stable with respect to the background.
Well, yeah, it's a composite. So he took one where he had the illumination.
They probably ran a flash and then, whatever.
I don't know,
right?
there's no shadows. He could have just taken a daytime picture of the terrain and
Oh, yeah.
toned it down and then used it.
Or just a longer exposure
Yeah.
with high ISO to get the terrain.
Do you
Some
think
reason-
these were activated by the camera? I mean, camera would open up if they saw and something.
No. He just had it doing, a series of photographs, and then he composited them, which
Okay.
probably was a heck of a lot of work.
Yeah.
I bet. This is really neat.
Yeah, you do. What did he use? He used 15 millimeter. Oh, these are 30-second exposures. So he did 30-second exposures and probably several hundred of them to get 66 meteors. And then he went through and picked out the ones that had trails he could use.
Well, you look at the length of the trails, and that's 30 seconds worth.
Yeah.
Yeah.
Well, or, whatever the meteor length was.
Oh,
Yeah.
true.
And as you get farther away from the radiant, which is here, the trails are more tangential to you.
Yeah.
So that are more
It's an
orthogonal.
optical illusion. They look longer, but they aren't.
Yeah.
That's right. It's a perspective. So there could be even some trails in here that are just dots.
Yeah. That's what
You
I was
look at
thinking.
it
That's
head on.
that's either a star or that's a head-on meteor.
Yeah.
It looks like the sun has just set on the horizon. It's brighter down there.
I'll bet those are city lights from somewhere far away,
Oh, yeah.
reflected.
Almost impossible to get a. We went to on the Rose Valley Road out of Ventura, figuring that'd be a good place to set up our scopes, and it was. But and because you're in a ring of mountains, but all the cities around there just still pollute the light sky.
Yeah.
Well, we're getting a full moon too this weekend, aren't we?
About a week from now. It was
Okay.
first quarter, I think, on Friday.
But most meteors go down, don't they, in the sky? These, for some reason, these look
No.
like they're going up. I don't know
No,
why.
they don't go down.
Well, they don't go down. They don't
There
come
was
down.
one really bright meteor that we saw that went almost all the way across the sky. That was a deorbiting spacecraft.
Oh. That'll be our ISS someday, won't it? Aren't they going to?
You know,
Well,
one thing
coming
heard
up,
that-
there's a Russian probe that was sent to Venus in the 70s that failed and never got out of Earth orbit. And it's going to be re-entering, and it's a tough chunk because it was meant to land on Venus with a thick atmosphere. And so it's probably going to survive to hit the surface.
So one of their,
Most likely it'll hit water, but
yeah, it's an uncontrolled re-entry. So
is that one of their Veneras?
yeah.
yeah,
Wow, they had a whole bunch of those. I only knew about one that took a picture on me
I think they
Venus.
had 8 of them.
Yeah.
Did they really?
And I think
Wow.
4 of them managed to send back pictures.
Yeah. Okay, this is moving right along. We're moving to the Swan Nebula. This is where it is.
Oh,
It's right in the center, right there, M17. And this is the Scutum star cloud. This is the center of our galaxy bulge, right coming out of the teapot. I can't, there's the teapot asterism, part of the Sagittarius constellation. And here is right above this is where our black hole is located in the center of our galaxy in this area.
woo-hoo.
It's Sagittarius A asterisk to avoid
Star.
confusion.
Yeah.
And this is extremely rich area. There's a lot of, if you miss M17, you're going to run into all sorts of interesting stuff there.
Even in binoculars.
Yeah.
I sent you a picture I took of it. And
Yeah.
one thing I don't like about the a lot of the pictures is they're overexposed or they try to bring out too much. And you like, for example, the Swan Nebula, it's hard to make out the shape of the swan because all the dark is gone. They've, highlighted that. They've gone in with the
Yeah, a lot of
lighting.
these names, as you're pointing out, a lot of these names are done by visual observers through a scope, and they don't get all the deep structure, which confuses the image compared to optical. But this is the swan. There's the swan's body and wings, and there's its neck and its beak.
It's interesting. I have that picture on 2 different monitors here. I have it on my cell phone, which is small, and then on my big, my computer terminal, my computer display.
Mhm.
And the swan pops out on my cell phone because it's small and it's all in my central vision. I look at the big one and it doesn't quite pop out the same.
Mhm.
Well,
This-
you posted something, Jerry, in your talking points that did look like a swan. You haven't shown it yet.
Yeah,
We'll
that's
get
it
to
right
that.
here.
This is the photo that Bruce is talking about. He sent it to me last night.
Oh,
Okay,
okay.
So this
But
is
in
his
your
photo.
talking points, there was something that looked like it had a crooked neck.
Yeah. Those are pictures that were discovery pictures, I guess, in one case. But they're drawings. They're not pictures.
Oh, okay.
They were later than Discovery, but they're by Herschel's son, by John Herschel, a couple of them.
Yeah. This
this
is
is
the
all
one that got the label the Omega Nebula, which I've always objected to.
There it is. That's the one. That's what I'm talking about.
When I see this, I think of this as the 2 nebula.
Yeah, it's only half a nebula. It's the other side of the Omega is gone.
Yeah. And here's another picture, I guess, from John Herschel. That first one was 1833. This is 4 years later. And I'm guessing it was taken, he drew it from Australia. or South
South
Africa.
Africa.
Yeah, South Africa.
It's upside down.
Yeah.
Is that a device or something?
No, that's his picture of the nebula, his
That's
drawing.
his visual impression.
It looks like a metal nutcracker or something that you could use on him.
It looks like a broken wrench.
Okay.
And
This
this
looks like a dinosaur.
this is from the U.S. Naval Observatory in 1875 by a Trouvelot.
Whoa.
It's a much more detailed, this is a bigger telescope. And as you get bigger, you collect more light, you see more structure, and the original impression, the visual impression gets buried in all this new detail.
But
Well,
it's
that's the
interesting. If you look at that second picture, the broken wrench, a lot of that structure shows up in here. So Herschel was doing a pretty good job.
Yeah.
You got to kind of
Yeah, you
flip
have
it
to turn
over,
this
but
over. You have to turn it over to compare the two of them.
yeah.
Yeah.
That could be the
So there's a
Millennium
big
Falcon.
void with a bun on top. Let's see if I can find that.
Jeez.
And that's
there's a
over
big
there.
void
Yeah.
with a bun on top.
Oh, right.
Yeah, he wasn't doing too bad.
Oh, I love this stuff. It's fascinating. This guy. That looks like the Millennium Falcon. I'm sorry.
I don't see that in there, but
Well, it could be one of those stormtrooper aircraft or spacecraft that fought on board the Death Star. Remember how they looked?
the Imperial Stormtrooper or the metric Stormtrooper?
Ones,
Good one.
ones that
This
had the
kinda
Force.
looks This kind of looks like a pterodactyl to me.
Yeah, you could play all kinds of games with these things. That's great. And that's all gas and dust with a bunch of stars in the middle.
Yes, in front of it and behind it, yes.
So,
Now this
okay.
is a photo from last week. So and it's pointing out what are coronal hole. The sun's very active right now. It's at near a peak of its cycle. And we had a CME, not a gigantic one last week. But this shows the active surface of the sun. This is I think this is hydrogen alpha light, but it sure shows a lot more structure than you see in my solar scope.
It might be a UV image, though. So you're getting
Yeah.
more of the hydrogen lines.
Well, the image we had yesterday at the observatory, there was a large hole, which looks like it's the one in the middle here.
No, that was a sunspot, Bruce, and the sunspot's off on the left here. That's the bright area. But these
Okay.
coronal holes showing up dark, these are X-ray or UV views, and that's different.
Okay.
But the corona is the outer level, right? The hottest. It's pretty hot
Yeah.
out there.
Yeah, this is the corona you see around here. And the fact that
Okay.
there's a coronal hole means the plasma can come right out of the photosphere and speed away unhindered. So this is prone to make CMEs.
And it's as hot out there as it is in the middle of the sun.
No,
Is it hotter?
it's hotter in the middle of the sun.
Yeah.
It's hotter than the middle of the sun where the
No.
fusion-
The middle of the sun is hotter.
Oh, okay. But
Or
still,
the core of the sun.
Yeah.
Yeah, Ron.
yes.
Yeah, the group, the Knack. Remember the Knack?
Oh, yeah.
They made the sun real famous. My Corona.
My corona. It was my Sharona, in case
That's
you want to
correct.
know. But you're right. It's a damn good beer, though, I'll tell you right now.
I like all these answers.
This is a coronal mass ejection.
This is a picture Tim drew from his little 60 millimeter.
Yeah.
I think this is an artist impression, isn't it?
No, this is a photo.
That's a
It
shot.
is. Okay. Wow.
Wow.
This
Can't
is
be a
August
photo.
August 31, 2012.
Hmm.
It's a composite image,
Okay.
and it does represent Earth to show this relative size of the CME. And this is the Earth down here. Of course, the Earth wasn't in this position or anything, otherwise it would have wiped out.
It'll be lights out.
But this is a hell of a lot of electromagnetic storm and ionized particles coming out. This is, what year was that? 2012. No, that was about 2 or 3 years ago. A CME came out and it surged through my surge protector and set it off. So I had to reset it. It had blown the circuit breaker in it. But the
DME stands for coronal, what's the
Mass
Okay.
ejection.
ejection? Okay. And that's different from holes.
Yeah, holes tend to promote these types of eruptions
Okay.
because it doesn't have to go and push all that those ions and electromagnetic fields aside to get out.
Okay. So it doesn't have anything to do with sunspots. They're different.
No,
They're
no,
different.
no.
They're
Yes,
somewhat related, but yeah, they're different.
Chuck, yesterday you mentioned that one of the customers asked, we were looking at prominences, and he asked if you saw a coronal mass ejection. You said it would look different in hydrogen alpha.
No, I said flares would look different.
Flares would look okay.
Yeah. Flares will often cause coronal mass ejections, but a flare, people think the prominences are flares. You know, the thing sticking out, they say, oh, there's a flare. But a flare is more short-lived and it would look more like a bright flash on the sun.
Yeah.
Not necessarily a quick flash. It could last for hours, but it's just would be a real brightening.
Now, what would this look like? Like a prominence?
Yeah.
This would look
Okay.
like a prominence that just kept going out into the
Like
space
kind
around
of
the
like your
sun.
suspended prominence that you were seeing yesterday.
Yeah, yeah. I was just gonna mention that. Okay.
Now, most of those prominences you see with our scopes are material cooling off as it falls back into the sun. The mass ejection, the magnetic field is lifting up and it brought material with it. But a lot of that material is now, if you look at it, it's streaming back into the sun.
You see it here. This is an oblique view. That's a loop, and it's going back into the sun on the backside out of our. We can't see it.
Yeah, if this, what you're talking about, I think is this.
No, I'm talking
No.
about the big thing that you have right
This
in the
here.
middle here.
This one, I'm not sure if this is a CME, then pretty much a large part of this stuff is going to head out into space. And if it happens to be heading toward Earth, which they usually do not, then we're going to get a Carrington event-like thing.
Yeah. But
Oh, a
Bruce,
big
yeah,
one.
even though this part on the far left, the ANSA of this thing, ANSA of this thing might be right now it may have a shape like a parabola. This stuff would escape, so it would break. It's like it would break the loop, and this stuff would escape.
Okay. So
Now
it's not following a magnetic line of force.
No,
Well, it
is.
is kind of, but then that part gets
Yeah, magnetic
accelerated
field,
enough to escape.
as Chuck points out, magnetic field lines do break, and they're loops, and they just continue with this mass of ions.
Now
Are we?
this is plasma, right?
Yeah.
Yes.
Okay.
So it's all charged particles.
Okay.
Fourth state of matter.
There's my hand. There it is, Ronnie.
And it is the source of some really hairy mathematics in the
I
field of
bet.
what's called
Is
magnetohydrodynamics.
it a somewhat similar phenomenon to the incoming stuff that makes our northern lights?
Yeah, that's when that stuff hits us.
Right.
Because that's our electromagnetic field.
Our magnetic field.
Magnetic.
Yeah.
Okay,
It
magnetic.
deflects it, and it follows the lines of force of our magnetic field, which go into the poles. So that's why you get the northern and the southern lights.
Yeah, the particles come in they're swept up to
pole.
the poles by our magnetic field. They enter the atmosphere there, they ionize our atmosphere, and then the ions relax. They capture, they relax back and they emit the light that you see as the northern lights. But if
When
you
the
have
lights
a big
like this
enough,
are dominantly oxygen fluorescing because of the green color. Is
yeah,
that
it
right?
depends which atoms are involved.
Yeah. No,
But-
on Earth, the northern lights typically are green.
Yeah,
Yeah, they are, aren't they?
Green and pinkish.
yeah.
Yeah. Well, that's
Nitrogen
hydrogen,
and oxygen.
right?
But the supersized version of the magnetic field on the sun, don't they come into the poles of the sun, the south?
They
No,
tend that way.
the sun is a much more disorganized field.
Right.
So that's why we have little blue blobs, blurbs, loops coming out all over the surface, having nothing to do with the general configuration of the
Magnetic
mass.
field lines don't have a start and they don't have an end. They're like a rubber band. And if you take rubber bands, put them in your hand, and then you rub them together into a ball, and then you look at the shape of individual rubber bands, that's what you're going to get in magnetic field lines. And every now and then, these magnetic field lines will get forced out of the sun because they're all wound up too tight. They break and then they reestablish themselves a simpler way. And that produces these solar cycles. When you were a kid, you had one of these balsa wood model airplanes that had a propeller and a real long rubber band running down it.
Yeah.
You wind the propeller up with your finger, and as you wound it up, you'd see the rubber band twisting up and twisting up. After the rubber band gets twisted up enough, it starts over twisting. It twists on itself. It's no longer an organized twist. It's a chaotic twist. Parts of it pop out of the surface to make room for themselves, and they stretch. And then if you keep going, it'll break. It'll relieve itself that way. And that's when your model airplane is giving a coronal mass ejection.
Well, then that would that be when the supposed polarity changes and suddenly our magnetic field is going to reverse and our compasses will point south?
That's different.
That's different than what you're talking about.
Yeah, I'm talking about the sun, which is much more dynamic and has much stronger magnetic field lines. What you're talking about is the pole reversal on the Earth. And the Earth is not a single dynamo. There's a number of dynamos that contribute together. And some places on the Earth right now, the north-south polarity has reversed. So, and the pole moves. Yeah. It's a vector sum of things. It's
I
not.
understand. Even on the sun, though, is one pole.
No. Don't think of it as single poles on the sun. The sun is a fluid mass and different parts are rotating differently.
Yeah.
So it's much more chaotic. It's like a whole bunch of little Earth fields all mixed together.
Oh.
Aren't magnetic fields, whether on the sun or the Earth, based on a plus on one side, a positive versus a negative? They're not.
No, it's not positive and negative. No,
they're not polarity. No polarity on that, like a magnet.
Well, there is. They call it north and
magnets.
south just for convenience. They got to call it something.
All right, think of the sun as a big bag full of little magnets, and you're shaking it up.
Woo! So I guess all stars are set up that way then.
Yeah.
We had a question yesterday, and somebody was wondering, what direction the sun was rotating. And I said, well, I don't know, maybe left to right, but I had a prominence that was at 3 o'clock, and later in the day it was at 12. So
some of that is because it was moving across the sky, from our point of view, because the Earth was rotating. And so the angle of the ecliptic was changing.
Okay.
Which way, whether the sun moves left to right or right to left is whether you're in the northern hemisphere or the southern hemisphere.
Yeah. And whether you've got a diagonal in your scope or not.
Yeah.
Okay. Boy, I'll tell you, that's one that I'd have to go to the Chuckopedia for sure.
But since the sun is rotating, it has a northern hemisphere and a southern hemisphere, wouldn't it?
You can sort of define it that way based on our pole, our north and south poles, but that's more the rotational pole.
North was defined as north long before anyone knew any magnetic fields were involved.
Yeah.
And then when magnetic fields were understood, they realized that the magnetic field should be north and south for opposites to keep it from plus and minus for electricity.
This is really washed out, this one. You're going to have to go to your other mode.
Somebody came up with a thought that if Pluto collides, since they do cross orbits, don't they?
This is a question that was asked of Astronomy Magazine.
Many times.
Yeah, probably.
Neptune, right? Not Uranus.
Well, Uranus is involved too.
It is? Okay. out there next to the
Can you see this?
Kuiper Belt.
Yes.
Okay. So these are several perspectives of Pluto's orbit. And basically what has happened is that Pluto and Neptune have formed a resonance, a 2 to 3 resonance. And since the Pluto does not confine itself to the ecliptic down here where all the rest of the planets are, and the rotation of the sun's equator, by the time they do cross orbits right here, but they're always coordinated, they're always in phase to not be there at the time that the orbits cross. So the orbit is there, but they're not there.
Okay. Okay.
So Pluto goes below our ecliptic sometimes, and then above it the other half. The other half.
Yes.
Okay.
Its
At an angle.
orbital plane is tilted with respect to the rest of the rest of the planets.
Yeah, and they're synchronized so that they don't really intersect at the same point at the same time.
So
That's good.
Are we saying it's possible they could collide, or
No, it's impossible
it's impossible?
unless
Yeah.
there's some other object that breaks this resonance.
And in the description that was in the handout, Uranus has an effect to try to destabilize it.
Right.
And so in the long-term future, there may be chaotic events that chaos might intrude and you might get it either tossed out or other weird things can happen.
Or the Voyager satellite.
Oh, yeah.
Or they
So
somehow find
this reminded me of Bruce and Farsad's talk
Oh yeah,
years ago, and I was wondering if Bruce, if you included Pluto in your calculations,
I did.
and did you put it in a tipped orbit like this? Did you
It
know?
had its. We put its orbital parameters in. We got them from NASA.
Oh, okay. Okay.
No, my simulation had 39 bodies in it. All of the 9 planets, if you
Yeah.
will, and their moons, the major moons.
Okay.
where does your planet 9 that they haven't found and your elusive sun's nemesis star come in?
Oh, that
They don't
nemesis
exist.
star is baloney. But
Planet 9, don't they think there's a 9th planet out there?
yeah, but
That's-
it's way out and it's affecting things in trans-Neptunian stuff.
That's
Way
still
out
up in
there.
the air. They're publishing papers on either side of that argument.
Yeah.
You think
So-
it might be in the Oort cloud?
But you heard it here first. Nemesis is now renamed Baloney.
Yeah.
So it's not
But they
orbiting
have
a-
found what they think might be a 5 Earth mass object out there.
Huh.
That Mike Brown is saying, well, it's not really right to be the one that we were seeing indications of. So we'll
a
see.
rocky one, not a gas one.
Icy one, more likely.
Oh,
Yeah.
okay.
Pluto, has atmosphere at some parts of its orbit and not at other parts because it's so cold out there that the atmosphere freezes into solids on the surface. And then at other times of the part of the orbit, it has an atmosphere because it warmed up slightly, and now the gas is in the atmosphere.
Whoa.
The reason they can tell that is because when the Pluto occults distant stars, sometimes the occultation is very quick and other times it fades.
And I did it. I did an occultation, and I think I was out at Baccara when this happened. I did get video of an occultation where Pluto was passing in front of a star, and I sent it in for analysis, and it did show the atmosphere,
Okay.
even with a little 5-inch scope, which
Very
is pretty
good.
amazing.
But that close-up picture taken by New Horizons of the large heart on the planet's surface is frozen nitrogen, isn't it?
Yes.
Yes.
Yeah, they're-
Campo Reggio.
It's
Yeah.
not snow. It's not ice.
It's like
water.
snow. Yeah.
Oh, it is?
Yeah.
Nitrogen.
It's nitrogen snow.
Yeah.
Yeah, we
Rather
can
than
freeze
water.
nitrogen. They use frozen nitrogen for cryogenics here on Earth, don't they?
Mhm.
No, they use
Liquid nitrogen.
Right.
Now I have to ask. I know. Did Mike Brown use this kind of orbital mechanics here to toss out Pluto as a planet?
No. I mean,
Okay.
it's part of the argument. It's part of the argument that it's in this tilted orbit.
Okay. It wasn't the tilted orbit, though.
But there's a couple of other dwarfs out there in the Kuiper Belt that are just like Pluto, right? But haven't really been named and were never made a planet.
Well, they've been named
Yeah.
mostly. I mean, some of them may still have just the phone number type name, but
Okay.
they're still arguing about how many and which one should be dwarf planets.
We do use,
Just
by
call
the
them
way,
all planets.
we do use solid nitrogen, frozen nitrogen in the big telescopes like Palomar. They put liquid nitrogen in, and then they draw a vacuum on it, and it actually freezes. It goes in even a lower temperature
How? How do they freeze it?
with a vacuum. They pull a
Just by
vacuum on
putting
it.
it in a vacuum? You would think vacuums would be absolute zero, wouldn't you?
I had
No,
a friend that worked there. He gave me the cook's tour of Palomar.
Well, what do we got here? Voyager, where is it now? Didn't get this headline, but they're still beaming into us at what, like 10 watts?
a very low data rate, yes. And a lot of their instruments are offline, I think.
Yeah.
Now, this scale here is log scale. It's not linear. So every bump here, every number is 10 times the previous. So this is 1, here Saturn's at 10. The termination shock and the heliopause are out around roughly 100, and these are AUs. So it's way out there. The Voyager is just right out here at the heliopause. And this is into interstellar space. When it goes 10 times farther than it is now, it will be here and enter the Oort cloud.
Oh, that's
The
where
Oort
Oort is.
cloud, the Oort cloud will go, it doesn't get as close to Alpha Centauri as this looks like it does, because this is a scale of 10 times 10 times 10.
Yeah, it gets about halfway there.
Yeah, it gets, yeah, good.
When does it become V'ger?
That's when it's shipped back to us.
Oh, okay.
It'll be a little beat up.
Yeah.
So Alpha Centauri has the same stuff going around it. It's a binary or a trinary?
Well,
I mean, the Proxima is the planet, I know, but are there
no,
three
Proxima
stars?
is the red dwarf star that's part of the triple system that
Yeah.
forms Alpha
And
Centauri.
it happens to be currently closest to us.
Yeah.
Got it.
And there are exoplanets around a couple of them.
Okay.
Oh, this is all overexposed.
I get one last thing. The heliopause is where there's no more influence of the sun.
No more influence by the solar wind.
Right.
Solar wind. Okay, thank you.
Solar wind is petered out. And it fluctuates. It's not a fixed point. During high solar activity, it's way out. During low solar activity, it moves back in. But it may
Okay.
not move in phase with the activity of the sun. But it's
It has
caused by
tides.
yeah. So
And
I
the
understand
Voyager-
this is washed out on the face of the moon, but you can see the phases.
Yeah.
These are all the same. This is Earth, and these are all the same phase. They're all waning gibbous. This is how the moon would look to you if you were standing at the North Pole, suitably clothed. This is in the Northern Hemisphere, how we see it roughly here, at 34 degrees north latitude. Here is what it looks like at the equator. See, it's laying on its side. Here it's flipped over, reversed in the Southern Hemisphere. And here at the South Pole, it's flipped from the North Pole. So whether the sun rotates right to left or the moon rotates right to left is all a matter of where you're standing on the Earth.
Oh,
You're upside down when you're down in Argentina,
Right.
in Australia.
The same deal for the quarter phase. This is last quarter. And for crescent, waning crescent, just before it becomes new moon.
wow.
So how it looks depends on where you're standing. And as Bruce points out, it's because some people are upside down in the south and people in the north are, because down is toward the center of our Earth, not this way.
Well,
I had shared that picture that I took out in the middle of Australia. If where it was wonderful. A dark sky, a whole bunch of stars, and Orion, for example, was upside down. People say, "Why is it upside down?" I says, "Because we're upside down."
Yeah,
Oh
it's not
yeah,
upside down.
Would it be fair to say, as I calculated once, that in summertime our sun is higher at night or during the daytime, but the moon is lower in the summer at night? And they
When it's
reverse,
full. Yeah.
and it reverses, and that's part and parcel of what we're saying here.
That's because we're not exactly on the ecliptic.
And we have a tilt of 23 degrees.
Yeah, that's what I mean. Yeah.
yeah.
Well, I just
So that
wonder if
reminded me of a phrase from, gosh, I forget which book it was, but someone was complaining about the universe being designed badly. And he said, for example, he wanted to study the big stuff. And he said, I want to know why, for example, the sun only comes out in the daytime. Why doesn't it come out at night when it would be more useful?
that's the flat earthers' position on things, I'm
Right.
sure. And this looks like Japanese anime cartoons.
The sun isn't moving. We are.
Yeah, well, the sun is moving, but not respect
Oh,
to us.
yeah, right. With respect to the
Right.
center of the galaxy, but
Now this Hubble, as our last topic today, Hubble just released, not Hubble, the Webb just released a picture,
So
an
the
infrared
sombrero.
picture of M104, the Sombrero Galaxy.
Oh,
This
wow.
is how we see it in visible light, very dramatic. This is a look through a lot of this dust and structure here, looking at just these clouds.
In
Now,
infrared.
this is one of those ring nebulas, it looks like, a ring galaxy. And the consensus seems to be that these ring galaxies are made this way because through a galaxy collision, and one galaxy hit this one and passed right through the center of it. And the result is this ring.
No trailing arms.
The arms are all wound up in there. Probably the thing that's left behind all is just the trailing arms. They're all merged, but the core arms and the core got blasted out.
And what you're seeing here in that upper picture is not so much emphasizing the stars, but emphasizing clouds of gas and dust.
Right.
you think
Well, I
that's an
have seen.
ultraviolet photograph or an infrared?
It's infrared.
It should be infrared.
Yeah,
Okay.
Hubble can take pictures a little bit in the UV, but Hubble Webb I don't think does. It just goes to the visible.
But Webb can go down to 25 micron wavelength for IR.
Yeah, that's way in the IR.
I know.
Yeah,
I
25
They
have
designed
seen.
it that way.
You're what?
I've seen pictures, gentlemen, of the sombrero that just looked like a Mexican hat. It had a bump in the middle.
Yeah.
I don't see that.
If this one weren't as long of an exposure as it is, you'd see that bump. Interesting.
Is that right?
Here's another galaxy on its side right there, and it still shows up very prominently here.
Wow. How far away is this sucker? How many millions of light years?
20 something.
20 million? Okay. It's not part of the local group then, is it?
Part of the Virgo cluster.
Yeah.
So something went through it, they think, but is nowhere nearby and it was
No,
way
it
off.
just kept on going.
God.
Most of them have an obvious collision part or aftermath in the vicinity, but this one doesn't seem to, and there was one other one that we looked at that didn't.
I don't know that M104 is considered one of those ring galaxies. I think that's just an artifact of what it looks like in the Webb picture.
Yeah, it was just my speculation here.
29.35 light years.
A million light years.
A million, 29.3 million light years. And Jerry, you're saying that they think it was formed by a collision of one galaxy?
No, I was just speculating that because we had a unit that we looked at about a year ago of ring galaxies, and the consensus was that ring galaxies are formed by collision. And I was saying, hey, this looks like a ring galaxy. Maybe this was formed by a collision.
But this is considered usually a spiral here. So this isn't, I don't think this is one that formed that way. but look up Hoag's object, Hoag, and that's a ring galaxy. Or look up the Cartwheel galaxy. There was a web picture of the Cartwheel galaxy, and those are where the rings are formed. That's where the stars are in the ring galaxies.
And
Is
those
it's a nice ring like that.
this looks like there's a core there, though.
Yeah,
Yeah,
there's a core.
Okay. Okay.
You said cartwheel. You mean pinwheel?
no, Cartwheel.
Cartwheel,
Oh,
yeah.
there's a
Cartwheel.
different one. There's two of them there, huh?
The pinwheel is M101.
Yeah, there's a pinwheel, there's a whirlpool. Those are spiral galaxies, but
Yeah,
cartwheel is a ring galaxy.
yeah.
Okay.
But anytime you see a galaxy that's shaped like a disc, it's turning, isn't it? There's no such thing as a flat disc that just sits there, doesn't move, I would think.
Right.
It's going to be a wheel. Yet the ellipticals are big puff balls, cotton balls, but they're
Now
also turning. Right?
there is a study that just came out that probably 1/3 of the galaxies are rotating one way and 2/3 of them are rotating the other way. And this is taken by the Webb as being, not the James Webb, but the internet, as being evidence that the entire universe is rotating and we might be inside a black hole. All that speculation is based on that, and it's mostly hype, because the study that looked at that, out of all the trillions of galaxies, they only looked at 264 galaxies.
Yeah.
So it's not a significant finding. But you will be seeing that. Just happened last week, I think, as I started seeing it. So
Yeah,
you will see that around.
That could be like a local eddy within the trillions of galaxies that we've cataloged.
There's a lot of things it could be, yeah.
Well, wasn't that the purpose of the recently retired Gaia, just to survey galaxies? And
No, Gaia was surveying stars in our galaxy.
Oh, is that what it was? Well, there's got to be something up there looking just for galaxies, isn't there?
There are.
That's the one Professor Wimberley was talking about Friday night, I guess.
Well, no, she did her work from ground-based telescopes because there's nothing in orbit big enough to see the faint galaxy she wants to see.
I thought we talked about a launch. It's happened or going to happen. I'm not sure.
There was a GOES or something that was going to be launched that would help her out.
Which, geez. Well, I guess we got through it again. And now how much can I retain that you'll tell me in the future, Chuck? I'm doing my best, but I just turned 79, and I guess that's going to do it. We've made the hour mark for this week's SBAU Astro Hour. I'd like you to join us next Monday morning, everybody, May 12th, for our 219th program. Till then, come to the museum. And Captain Outreach, Chuck, you want to give us our official goodbye, farewell, as you sign off on your emails?
Hasta Nebula.
Bye, everybody.